So this is called adding rational expressions. And we're going to focus on adding rational expressions today with like, or sometimes instead of like, people will say common denominators. Adding rational expressions, and for today we'll focus on like denominators. We're also going to talk about subtracting, but I'm not going to put that in the title because the title's already long enough. Technically, subtracting is just adding a negative, right? So we're adding. All right. So let's start out with just a really simple example. Let's say I had something like this: x over 2x plus 4 plus x over 2x plus 4. So the first thing I'm going to look for in these is if there's anything that I can cancel before I start. If there's anything that I can simplify before I start. Well, you do sometimes have to be strategic about that. So, for example, here, I have like denominators. If I have like denominators, I really don't want to cancel anything, because that's actually what's most important before adding. Okay. Now, in this case, there's not even anything that I could cancel anyway, so it's not really an issue. So noticing is the like denominators, 2x plus 4 and 2x plus 4. Just like adding fractions, if we have like denominators, we just add the numerators together and keep the denominator. So I just have x plus x, which is 2x, over 2x plus 4. And now I'm going to look again and see, can I cancel it?
You can cancel 2x.
I can't cancel 2x because in the bottom I have 2x plus 4.
You can take out 2.
But what I can do is pull a 2 out of the bottom. So up top I have 2 times x, and bottom I have 2 times x plus 2. And then I could cancel a 2. Right? And if they ask me for my excluded value, my excluded value would be whatever makes the denominator 0, which would be negative 2.
Oh, no.
0 wouldn't make this denominator 0. 0 would make the numerator 0. So the steps of this are relatively straightforward. You guys already know how to add fractions, right? You already know how to reduce these. So we're kind of just combining two things that you already know how to do into one.
What if they don't have like denominators?
We're not going to get into that today. Okay, we'll get into that tomorrow. What can happen though with these is you can get something a little bit more complicated. So for example, what if I had something like this? X over, actually let's say x plus 1 over x squared plus 15x plus 56 plus 7 over x squared plus 15x plus 56. So again, the most important thing here is that I have common denominators. I am kind of looking to see like what can be factored and what can't. Like I would definitely notice that this denominator can be factored. I might not factor it yet because I don't really want to cancel anything. It doesn't matter. I'm going to either have to factor it now or I'm going to have to factor it after I add. And it's actually better to be in the habit of factoring before you add. Okay? So what I'm going to do is, I know it's the same thing, so I'm just going to factor it once. And I notice factors of 56 that add up to 15 are 7 and 8. So what I really have, and again, like I would maybe do this actually as one step. I know that this denominator is x plus 7 times x plus 8. I don't necessarily want to actually write that down twice. So what I might just say is, I know that this is going to equal something over x plus 7 times x plus 8, right? Because the denominator is the same. I don't need to like rewrite each fraction in this case. I know that this is what that denominator equals when it's factored. And then I look at the top, x plus 1 plus 7 is x plus 8. I combine my like terms, right?
Oh,
and then I can cancel the x plus 8. So I would have 1 over x plus 7.
pretty much what we've already done, just adding.
Yeah, so there's not really much new other than just the fact that we started with a plus symbol in between.
And
Right? We know about canceling, we know about adding fractions.
But on the homework, will all the denominators be the same?
On this homework, all the denominators will be the same. Yes. Okay, what if I had something like this? What if I had 2x plus 1 over x squared plus 3x plus 2 minus. Think about what that minus means. X squared plus 3x plus 2. So same denominator. And then I had x minus 1. Well, so if I'm subtracting this from this, what that means is that the minus applies to everything in the numerator. Okay? So I've got the same denominator. I would probably factor this, right? So factors of 2 that add up to 3 are 2 and 1. And then when you subtract, there's a couple ways to do this or to think about it. One is to just say, okay, if I'm subtracting this numerator, I'm just going to turn this into a plus, and I'm going to make everything in the numerator the opposite sign. The most common mistake is to say, okay, minus x, and then, right, because it said, originally it said minus 1, is to just do minus 1. So we'd say, okay, 2x minus x is x, and then 1 minus 1 is 0. But remember, it's 1 minus negative 1. So that's why I think doing this step of just saying, okay, make this a plus, change the sign of everything in this numerator, it's just going to save you kind of a headache of keeping track of your negatives. So like we said at the beginning, subtracting is adding a negative. Okay, 2x minus x is x, and then we actually have here 1 plus 1, 2 so x plus 2. And we can cancel those out. So we have 1 over x plus 2. Okay. I think let's just do one more example with subtraction. Let's say in the bottom, what if I had 2x squared plus 5x plus 7 over x squared plus 6x plus 5 minus, keep the denominator the same, and then let's say up top I had x squared minus oh no, sorry. Okay. So same denominators.
So we can factor or like
Yeah, so let's think about what this would be factored.
x plus 5x.
Plus 5x plus 1. That's going to be our common denominator. And then let's just distribute this negative, right? So if I make this plus, this becomes negative, this becomes plus, this becomes plus. And then I just line up my like terms. So I've got 2x squared over here, and I've got minus x squared.
Wait,
So
what
that would
after
be
that?
x squared. No. Yeah, that's a really good question. I would not factor that
And then would it just be
in
9x
this
plus
case.
8?
Because if I factor it, then I have to distribute it to add. You see what I'm saying? Like, okay, we'll get there in a second. Okay, and then I've got 9x and 8. Now I would factor this.
How did you get x squared?
So we have 2x
Oh, wait,
squared
never mind.
minus 1x squared, right? Okay, good. And 5x plus 4x. And 7 plus 1. So now I would factor this. It would be x plus 8 and x plus 1. And then I would cancel the x plus 1. So I would end up with x plus 8 over x plus 1. Right? Now, here's the thing. If this, first of all, I don't think you can factor that. Like factors of 14 that add up to 5, I don't think they exist. But if you could factor it, you don't want to. Because if I had something like this in my numerator, x plus 3 times x plus 5, and then I had to add 6x plus 7 to that, I can't really do that. I would have to distribute this first and then add these things to it. Okay. So it's kind of, the thing about these problems, and as we get into more complicated problems, there's not necessarily always a right decision. Like, I think with easier parts of algebra, there's kind of always an algorithm. There's always a set of steps to get the answer. As we get into more complicated versions of this, that's not always going to be true anymore. You're going to have to try to make the decisions that make your life easier. And so, for example, since we have common denominators, we want to keep common denominators. Since we have this factored out, it's easy to add to this. We want to keep it. I mean, not factored out. We want to keep it not factored out.
There would be some times where like factoring in would make sense.
Yeah, not on the homework tonight, but as we get into more complicated ones, you will sometimes see stuff like that. Like, oh, maybe I should factor this because then I can cancel it. And that actually make it easier. Yeah, we will see examples like that. But not tonight.